Excellent. Okay, so we just finished with our previous lecture what I would consider Unit 1 of the course, which was API programming and all the considerations that go into software engineering principles and practice for designing a good package of software that can be shared with other developers. So I now want to move on to Unit 2, since this is now our third week, into the collections framework and generics. And so the collections framework is a pretty big and pretty important, pretty critical package in Java. And by examining it, we can see how it was actually designed, which will give you some better impressions on how you might design your own APIs moving forward. Not just that, though, you'll likely have to use the collections framework with any real application that you would design in Java. With that said, let's get going into the slides here. So the collections framework in Java is one of the most valuable and interesting topics in the Java language. Without using the collections concepts, you wouldn't be able to develop any production level software applications. So it's pretty critical that anyone who's a Java developer, anyone who's a Java coder, is able to know how to use the collections framework effectively. And in fact, according to Sun, it's now Oracle. So according to Oracle, let's update this now. The documentation among all the Java concepts, Java collection frameworks is the most important concept. So it just illustrates that even the curators of the language sees the importance of this particular package inside of the Java standard library. So in the Java collections framework lecture, we will cover the following topics in depth. What is a collection in Java? We'll give some examples of collections. We'll give types of objects stored in a collection, or we can also call it the container object. We will examine what is the need for collections in Java, and then what is the collections framework in Java, and then we'll discuss a difference between the array that you've already covered and what collections are, which you've kind of seen. Array list is part of the collections framework in Java. So if you have any familiarity or exposure to array lists, or you're kind of ahead of the game and know a little bit about the what it provides over what arrays provide. So what is a collection in Java? Well, technically, a collection is an object or container which stores a group of other objects as a single unit or single entity. Therefore, it's also known as a container object or a collection object. So a collection object has a class that is known as a collection class. All collection classes are present in the java.util package. And of course, if it hasn't been explained already, util stands for utility. And so there's a group of collection classes in the framework located there. So that would be part of the API you'd want to examine as you go to use any of the things we're going to talk about in today's lecture. So just a quick example of what a collection would be, how it would be used inside of the Java programming language. Here's an example of a list of cities. Here, the list of cities will be represented as a collection of strings. So a list data type is a collection object or a container object that can hold other Java objects, similar to what an array does. And here we're just constructing a new array list. And then once we have this container class created, we can call methods specific to it that allows us to manage the internal data inside of that collection or that container. So inside of the cities variable then, which is a list of strings, I could then add New York or Mumbai or any other string actually into that collection. So since we're talking about types of objects that can be stored in a collection, or what we'll call a container object, there are two types of objects that can be stored generally in a collection that we'll want to kind of be able to identify based off of the type of collection we'll be using. So you have homogeneous and heterogeneous objects. And so just to distinguish between those two, a homogeneous object just means it's of the same type. It's objects, homogeneous objects are a group of multiple objects that belong to the same class, whereas a heterogeneous objects would be a group of different objects that can belong to different classes. And so some containers are going to require homogeneous objects to be contained in there, where others would allow for heterogeneous objects. Another thing we should take a look at before really evaluating what type of containers we have are going to be the concept of duplicate objects or unique objects. So that's another way we can divide our objects into ways we can contain them. And so for duplicate objects, these are where you have multiple objects of a class that can contain the same data. And so here, these aren't the same object, right? In memory, these would be, in this example here, we have a person constructor. We're going to invoke the person constructor twice and save it into variables. So we're creating two different instances of person, but since both these person instances have the same name, and if we define equality between these two person instances based off of the name, then we would consider those duplicated objects. So objects that essentially have the same value when compared to one another, versus a unique object where we would have each object that we would want to try to contain have a different set of values or not be what we consider equal to one another. So again, we're going to want to pay attention to homogeneous versus heterogeneous and unique versus duplicate objects, because there's some containers that will allow for subsets of those to be set into there. For instance, like sets or maps are going to require some kind of unique values to be put into the container, whereas lists don't require that. They can have duplicate objects put into them. Okay, so before going too deep into the collections in Java, I really want to establish a foothold for all the ways we can store values in Java, just to ensure that everyone from a ground zero, from a sum zero game, knows all the storage operations available to us. So the first one you probably learned was the variable approach, where we can just store a value in memory based off an alias. And the second would be a class object approach, where you could define a class that has a multiple, that could then have multiple sets of values inside of that class, and then you can instantiate that class. And then you probably also learned about the array approach, which is most similar and actually is defined as a type of collection, but it's not part of the collections framework. And then we would have the collection object approach. So before moving to the collect object approach in detail, let's take a quick examination as to the limitations of the three prior approaches. So the limitations of variables is that they can only store one value at a time. So that's super limiting. The readability and reusability of the code will go down if all of your storage operations are done with single line variables, and the JVM will take more time having to execute all those statements if you don't find a way to continuously insert all your items together and manage them. So that's not a great approach, right? So we really rapidly moved away from that, even early on, probably mid-semester of Java 1. And then you have the object-based approach. And again, the idea here is that it's great for storing a fixed number of different values. So suppose I had created this class employee, and my class employee had an int value, that represented the employee's ID number and a string value that represented the employee's name, that's a great way of storing those two fields that relate to employee, but this isn't a great way of containing multiple objects in and of themselves. And then we have the approach-based, the array approach. But the limitations here is, first of all, you can only store multiple fixed numbers of values of homogeneous data types, right? So you have to declare the data type of your array, and then you have to know the size of the array before you start using it. So you cannot store different class objects in the same array. Because the array can only store one data type of elements. And an array is static in nature, so it's fixed in the length and size. So you can't change the size over the duration or the life cycle of your application's runtime. We can add elements at the end of an array easily, but adding and deleting elements or objects in the middle of an array is difficult. It's not handled internally by the array at all. You cannot insert elements in some sorting order either using an array concept, because arrays don't support any method. So you would have to use the java.util.arrays class to be able to get any of those functionalities. So you have to use a helper API to be able to perform those tasks for you with an array. And then you can't search a particular element using an array, whether the particular element is present or not. And so there's a lot of things that you would like to have built into arrays that make it easy. And Java does supply the arrays utility class to give you some of that functionality, but the collections API or the collections framework is really designed to alleviate a lot of the limitations that arrays actually have. Now, so what is the need for collections in Java? Well, using the collection object approach, by using these collection objects, we can store the data or different data without any size limitation. Thus, technically, we can define the collection as a collection in Java is a container object that is used for storing multiple homogeneous and heterogeneous duplicate and unique elements without any size limitation. So effectively, no matter how you need to store data, you can rely on the collection framework to do that for you. So what is the collections framework in Java? Let's finally take and examine that. Well, it's a framework in Java, as we talked about before when we were looking at JUnit. A framework in Java is a set of several classes and interfaces which provide a ready-made architecture, but then you plug in your own code for it to actually fully work. And so a Java collections framework is a sophisticated hierarchy of several predefined interfaces and implementation classes that can be used to handle a group of objects as a single entity. And so in simple words, a collection framework is a class library to handle groups of objects. It is present in the java.util package, and it allows you to store, retrieve, and update a group of objects. So collection framework in Java supports two types of containers, one for storing a collection of elements that's simply called a collection. The other is for storing key value pairs, which is called a map. And so we're going to discuss both types over the course of this unit 2 of 2120. The Java collections framework provides an API to work with data structures such as lists, trees, sets, and maps. And really my goal for this set of lectures is to really impress upon you what list, trees, sets, and maps are, how you can easily implement them with the collections framework in Java, and when you might select to use a list versus a tree versus a set versus a map. Okay, so what is collections framework? Okay, let's take a look at this. The list of interfaces defined in our Java util package is going to be this. So just like I was trying to illustrate with good design principles, one of that is programming to the interface, and how I'm challenging you to do that in your first homework, you can kind of look as a reference how collections framework is organized. So you'll see that the API, the underlying implementation of everything is built off of a collection of interfaces, and interfaces are just they just contain abstract methods. So it's a collection of related abstract methods that any abstract class or class, any Java class, can come behind and gain membership by implementing those methods. And then it can become a member of collection or comparator or dequeue or enumeration or any one of these. So you can see there's a decent collection of different interfaces that define the different types of collections or containers that we might need to utilize in our own applications. And so this would be at the most abstract level. And so there would be classes inside of the collections framework that would come behind and implement these, but then we can create a variable of type list, for instance, and it could be any type of list. It could be a array list, it could be a linked list, it could be anything that ends up implementing that interface. And then just taking a look at the classes that would be defined, you can see then we would have our concrete classes and our abstract classes. So our abstract classes would have some methods, right? Or some fields that are congruent, that are compatible with multiple concrete classes. And the concrete classes are the ones we'd actually rely on to actually build out, to construct instances of. And we'll go through what these collections are throughout the course of these lectures. But again, you can see that the collection of interfaces and classes is quite wide to go ahead and utilize. Okay, so what's the difference between arrays and collections? I think we really cover that when we're talking about the limitations. I think here we're just talking about arrays are fixed, whereas collections can increase and decrease, and where arrays are not recommended to use with respect to memory, whereas collections are recommended to use with respect to memory, whereas arrays are recommended to use with respect to performance, but collections are not recommended to use with respect to performance. So you have this at odds between memory and performance that could potentially be part of your decision-making protocol while you're designing what collections, what container class to use. Arrays can store only homogeneous data elements, but collections can hold both homogeneous and heterogeneous elements, and arrays do not support any method, but collections support various kinds of methods. And finally, arrays can hold both primitive and object types, but collections can only hold objects. They can't hold primitive data types. And again, our get around for that, as we kind of mentioned before, is Java's mechanism to be able to auto box and unbox primitive data types into reference data types and back. And all of the reference data types for the primitive data types are defined in the java.lang package. And okay, so the advantages of the collections framework in Java are that the collections framework reduces the development time and the burden of designers, programmers, and users, right? So you don't have to focus on building the mechanisms, the methods to go ahead and like search or sort or organize collections of data, right? That's the entire point of the collections, is that it has all those implementations pre-built for you. Your code is easier to maintain because it provides useful data structures and interfaces which reduce programming efforts. So there's sometimes behaviors that you need to have when you insert and extract data from a container. And so there's a diverse set of behaviors you can rely on from the collections, and we'll go into that, and I'll try to give you a good homework assignment that'll challenge you in using what we'll talk about with this unit. The size of the container is growable in nature, right? So it's not finite, it's not fixed. It implements high performance of useful data structures and algorithms that increase the performance. So the thing about the collections framework is that it's super tuned for the JVM. So you could potentially design your own data structures, your own containers, classes with its own behaviors, but chances are it's going to perform worse than if you use the pre-built ones, because there was a lot of effort to make these as performant as possible. And then, of course, it enables code software reuse. So you don't want to keep reinventing the wheel. If there's already a tool available to you in a pre-existing package, look for it and use that. Don't try to build it yourself. Try to focus on the part of the applications that you actually have to construct to get your minimal viable product or MVP built. Okay, some limitations of the collections frameworks in Java. Well, there are two limitations of the collections framework in Java. One, care must be taken to use the appropriate cast operation. So, and two, you have to compile type checking is not possible. So in terms of, does a collection object store copies of other objects? No, a collection object works with reference types. It stores references of other objects, not copies of other objects. And again, a reference is just like a memory address of where that object exists at. And then can we store primitive data types in a collection? No, collections stores, they can only store objects. And again, this is fixed. Let me put, this is fixed here with auto boxing and unboxing. Compile type checking here is not possible. Well, we kind of have a fix here with what is called a type parameter, aka generics, which we'll cover in more detail, and kind of gets lumped into the collections framework because we rely on the type parameter to be able to get a lot of type checking for our collections type. Okay. So let's talk a little bit about the collection hierarchy in Java. The hierarchy of the entire collection framework consists of 4 core interfaces, such as collection, list, set, map, and then 2 specialized interfaces named sorted set and sorted map that are used for sorting. And all these interfaces and classes for the collection framework are located in java.util. So the package that the first package you probably learned about. Okay, so to give you a diagram of what this hierarchy looks like, I have here included it. So right here, your reds are your interfaces, your greens are your classes. The arrows represent when one inherits or implements from the other. So you'll see the root of the collection framework is iterable, things that are iterable. And so collections is going to go ahead and extend iterable. And then we have list, queue, and set, which are going to extend collection. Now, all of these themselves are frameworks. Are interfaces. All these are interfaces. And then array list, linked list, vector, stack, all these would represent concrete collections, container classes we can actually use, and they would all be considered a member of list. So if you're building out software, if you want it to be designed in a way that a developer can use whatever kind of concrete list, whether it's an array list or a linked list, you'd want to use the list data type, the more abstract type. Okay. So the basic interface of the collections framework is the collection interface, which is the root interface of all collections in the API. It is placed at the top of the collection hierarchy in Java, and it provides the basic operations for adding and removing elements in the collection. And again, hopping over here, it'd be right here. The collection interface extends the iterable interface. The iterable interface only has one method called iterator. The function of the iterator method is to return the iterator object. Using the iterator object, we can iterate over the elements of the collection. List, queue, and set have 3 components which extend the collection interface. Here, list, queue, set extend collection, and collection extends iterable, which means by default, list, queue, and set also extend iterable. And then a map is not inherited by the collection interface because it's modeled in a different kind of way. And we'll look at that when we get more to maps. Let's talk a little bit about the list interface though. So this interface represents a collection of elements whose elements are arranged sequentially ordered. So lists conceptually are probably the most similar to an array in that regard, right? Where we have a sequentially ordering of our array items. List maintains an order of elements, which means that the order is retained in which we add elements and the sequence we will get while retrieving elements. So again, just like we would add elements one after the other in an array, you maintain the original order of how things are inserted into a list. In other sets, it's not guaranteed that you will maintain the order of things that are inserted. Like for instance, there's no guarantee with sets for that. So that is a nice thing about lists, is that it does maintain your insert order. We can insert elements into the list at any location. So you can pick an index at which to insert your elements at, whether it's at index 0 or at the last index or some index in between. The list allows storing duplicate elements in Java, right? So they don't have to be unique. Again, I'll just distinguish that right now from sets where all the items have to be unique inside of a set. And some examples, some concrete examples of a list would be an array list or a vector or a linked list. Those are three concrete classes that implement the list interface. So let's parallel that to the set interface, since I've been contrasting the list interface to the set interface. So this interface represents a collection of elements that contains unique elements, i.e. it is used to store a collection of unique elements. So a set interface does not maintain any order while storing elements and while retrieving. So we may not get the same order as we put the elements in. So all the elements in a set can be in any order. So set does not allow any duplicate elements, right? Hence the fact they have to be unique. Some examples might be hash set, linked hash set, and tree set classes implement the set interface. And sorted interface extends a set interface as well. It can be iterated by using iterator, but cannot be iterated using list iterator because it's not a list. So you'd have to use the more generic iterator, the parent of list iterator, to iterate across a set. Okay, let's talk about the sorted set interface. This interface extends a set whose iterator traverses its element according to their natural ordering. So the difference between a set and a sorted set is that with a set, you're not guaranteed any kind of order when you put a element into it. And a couple of stipulations is if you try to put a duplicate element into a set, it just ignores that, right? It'll only hold a unique set of elements. A sorted set has the same property as a set, where it can only hold a unique set of elements. However, it will hold those elements in a particularly sorted order as it inserts them. And so for instance, tree set implements the sorted set interface. Then we have a queue interface. A queue is an ordered of the homogeneous group of elements in which new elements are added at one end, the rear, and elements are removed from the other end, the front, just like a queue in a supermarket market or any shop. So you think of it as just the line. It's a data structure. It's a container type where the insert and the insert and extraction from the container object has a well-defined behavior. And so this is usually called a FIFO ordering if you haven't heard of it before. And FIFO stands for the first one in is the first one out. So again, it's like if you go to the grocery store and wait in line, the first person, second person, third person, then the first person to come out the line is going to be the first one in, and the second and the third. So the interface represents a special type of list whose elements are removed only from the head of the list. So linked list, priority queue, array queue, priority blocking queue, and linked blocking queue are all concrete subclasses that would implement this queue interface. DQ interface. A DQ is what's called a double-ended queue. It's a sub-interface of the queue interface, and it's usually pronounced as DEC. Oh. The interface was added to the collection of the framework in Java 6, and the DEC interface extends the queue interface and uses its implement DEC. The hierarchy of the DEC interface is shown in the below figure here. So again, if we see that we have the collection interface, and our collection interface is extended by the queue interface, and then our queue interface is extended by the DEC interface, and then our DEC interface can then be implemented by either a linked list or an array DEC, and then these would be the concrete classes we can use to actually build a DEC. So with the DEC interface, it's a linear collection of elements in which elements can be inserted and removed from either end. So you could either add and remove from the head, or you can add and remove from the tail. Or often is the case, you have the ability to even add to the head and then use the removal method from the tail. So you're not limited on how you insert or remove from head to tail. So it's a really flexible data types where you get to decide whether you want to use it kind of like a queue or kind of like a stack. Okay, let's talk a little bit about the map interface. A map interface is not inherited by the collection interface. It represents an object that stores and retrieves elements in the form of a key value pair, and their location within the map are determined by the key. So the hierarchy of a map interface is shown here, where we would have the map interface. And so we have the sorted map interface, which would extend the map interface. Examples of the concrete classes would be like a hash table or a hash map that would implement off of the map interface. Or you would have, say, for instance, the tree class that implements off the sorted map interface. And again, the defining characteristic between a map and a list is that a list is a sequential set of values. And if you wanted to grab a particular value, you use the indexer, like what its position is within the list, the numerical position where it's at in the list. Well, map conceptually is kind of like a list where it's a collection of values, but instead of using numerical values to describe the position of the elements, you use a key that so you can look up a position. And the key could be anything. The key could be a string, for instance. So say, for instance, inside of a map, you could have the string that is, say, for instance, New Orleans. And then the value could be a instantiated object that represents a city that models New Orleans. And then you could have another key that's maybe Chicago. And then the value that corresponds to that key would be the instantiated value of a city that models Chicago. So it gives you more flexibility in defining what the indexer is. Instead of it just being tied to a number, you can make it any type of Java object that you can index into, which offers a lot of power in being able to look up values on your container class. Okay, so with the map interface, map uses a hashing technique for storing the key value pairs. It doesn't allow to store duplicate keys, but duplicate values are allowed. So just like a set has to have duplicate values, a map has to have unique keys. You can't have two keys that are the same. And that shouldn't be a surprise, because again, conceptually, maps are very similar to lists. And with lists, you can't have duplicated index values, right? You have a unique set of index values that go from 0 to whatever the length of your list minus 1 is. So here, this is just saying whatever you're using to define your keys, they have to be unique. And then hash map, hash table, linked hash map, tree map are all classes that implement that map interface. And then with the sorted map interface, well, this interface represents a map whose elements are stored in their natural ordering. So just like you have a sorted set, you can also have a sorted map. And here the sorting is done on the keys, whereas in the sorted set, it's done on the values. And so this should highlight the fact that both maps and sets, when they're inserted into those containers, aren't necessarily stored in the order in which they're inserted. So if you want some kind of ordering applied to your map or set, then you can use a sorted map or a sorted set for that. And just an example of this would be a tree map class, for instance. So the methods of the collection interface, the thing that defines any interface, anything that wants to be a member of the collection interface, it has a total of 15 methods for manipulating elements in the collection. And that means every implementation for a collection interface has to have these 15 methods. So this is really good to know, because this defines effectively what you can expect all these containers to do. And again, this is the nice thing about the concept of programming to an interface, is that the interface kind of, these Java interface source code files kind of represent small pocket APIs that you can look at and know what any inherited object's going to be able to do, be capable of doing. So let's go through some of these methods just so that we know what to expect from them. We have an add. So this method is used to add or insert an element into the collection. And so the general syntax for an add method is we can pass in some object as a parameter, and it's going to return back a Boolean value. And the Boolean value is going to be true if it was successfully added, and false if for some reason it didn't successfully add. And an example of when it might not successfully add is if, for instance, duplicates aren't allowed. So like for sets or maps, you might try to insert an item that's already inside of the set. So in that instance, it would return false on trying to or attempting to add that element. And then you have an add all. So this method adds a collection of elements to the collection. So it returns true if the elements are added and false otherwise. So this allows you to take one collection and effectively merge it into another collection. You have a clear method. This method clears or removes all the elements from the collection, and this doesn't return anything. You have a contains method. Here it checks that an element is present or not in a collection. And so this is going to take in as a parameter a element, and then will return true if the element is inside that container object, or false if it is not. And so it obviously has to search the container all the way through potentially to identify whether that item's in there or not for you. We have a contains all. And so this method checks that a specified collection of elements are present or not. And again, it returns true if the calling collection contains all specified elements, otherwise it returns false. So here we can pass a collection of elements, and as long as all of them are a subset of the larger collection, you will get a true returned. Equals, we'll check equality with another object. In this instance, we could see if one of our collection instances is equal to another collection instance, and that equality would be defined on the number of items and the ordering of items inside of our collection. If ordering matters, so for sets, it wouldn't matter. For maps, it wouldn't matter. For lists, it would matter. Hash code returns the hash code number for the collection. A hash code, if you haven't gone into it, is a unique identifier that is given to an instance when it's first instantiated. If you've ever called the toString method before overriding it, you get a combination of its class name and its hash code value, because that produces a unique value for that string. The is empty returns true if a collection is empty, if a container class is a container instance is empty, and false if it's not. The iterator method returns an iterator instance, And so the iterator instances we will talk about in a future lecture, but we use the iterators to be able to traverse, to be able to navigate, to be able to walk down our collection and do interesting things with it, to be able to find elements or seek elements out. It does what it's called, iterates. We have a remove method. It removes a specified element from the collection. And again, we pass in an object and it's going to return true or false, or whether it successfully removed that item. Again, it would return false if you try to remove an element that's not inside of the collection. Remove all will remove all the elements from the collection. And again, it will return true if only all those elements are removed, false otherwise. And again, the remove all is going to expect a collection data type to get passed to it. Retain all is a method that removes all elements from the collection except the specified collection. So you can think of it as kind of the inverse of remove all, where remove all removes everything that's defined inside that collection from the container class instance. Here, this will preserve all the things that you pass in to the retain all, and then it removes everything else. And then again, it will give back a Boolean value to let you know whether it was successful or not. The size method returns the total number of elements in the collection. And again, that returns back as an integer. And the size is different than a length, right? The length usually refers to the array, how many elements an array can hold, and length is typically fixed, whereas the size represents the number of current elements that the container or the collection holds, and that's something that can change over time. So you can start with a size of 0, and then go to size 1, and then go to size 2, and then size 3, and then back down to size 2. So this is something that's mutable over time, which is not what a length value is in an array. Then you have a method toArray that actually returns the elements of a collection in the form of an array. And so the array elements are copies of the collection elements. So for instance, it would return, and so sometimes you need to have your collection data type as a primitive array type. And for those instances, you have this method to be able to always rely on, since it's part of the collections interface. Every collection-based concrete class should have that to easily cast effectively any data type into a simple array. And then also you have another toArray method that's going to, so here, this is going to return an array. Yeah, this is the same thing. It just returns an array that contains all the elements, invoking it. Okay. So the collections classes implement the collection interface. They are defined in the Java util package. So again, you can always go to the Oracle API for any for more specific information and a full listing of all the methods and explanations. Some of the classes provide full implementations that can be used as it is, and others are abstract that provide basic implementations and can be used to create concrete collections. It's good to know both the collection of abstract classes and the concrete classes. The abstract ones are clearly the ones that have the term abstract in front of it. So you see that there's a naming convention here for abstract methods. Typically, if it's going to be an abstract collection, you call it abstract collection, abstract list, abstract queue, abstract sequential list, and abstract set. Whereas your concretes will have just very specific names for what they're modeling. So here, an array list is a list that's built on top of an array. So it builds all the methods that a list needs using an array as the underlying data structure. Here you have a enum set, hash set, linked hash set, linked list, and so forth. So your abstract collection implements most of the collection interface. It is because it's an abstract class, it can actually have concrete methods. So here, the ones that would be common will be implemented inside of, from the collection interface will be implemented inside the abstract collection. And so it's a superclass for all the concrete collection classes. Abstract list extends abstract collection and implements most of the list interface for you. Abstract queue extends the abstract collection. So this is kind of like the mother class for a lot of the more specific abstract classes, and implements the queue interface. Abstract sequential list extends abstract list and uses the sequential order to access elements. An abstract set extends abstract collection and implements most of the set interface. Now, for the concrete collections in Java, we have an array list, which implements a dynamic array by extending the abstract list. We have an enum set, which extends the abstract set for use with the enum elements. And so enum is a particular type. It's another top level type. So if you're not super familiar with enum, because I don't know how detailed they go in with enums, you actually have classes, you have interfaces, you have records, you have enums are all top level Java keywords. So enum is a closed set of values that you can model as a set. A hash set extends the abstract set, and it's used with a hash table. A linked hash set extends the hash set, and that allows for insertion order iterations. A linked list implements a linked list by extending the abstract sequential list. A priority queue extends the abstract queue to support a priority-based queue, and then the tree set extends the abstract set, which implements the sorted set interface. Really, the important thing about knowing all this is you could see how all of the hierarchy ends up implementing into concrete classes that allow you just to instantiate them. So again, we're kind of opening up this box and we're seeing what implements what extends what. And that's nice to know in case you ever have to make your own custom implementations. You can, since you have abstract classes, you can use an abstract class to create your own custom class, or you can just use these concrete ones. And once you understand what these concrete ones do, once they model, it's much easier just to use these collections framework than to build all this stuff yourself. Okay. Let me jump now. So that's kind of like the quick overview of the collections framework.